Welcome to another episode of Ship It. I'm Gerhard Lazu, and today Zach Smith, Managing Director Equinix Metal, is sharing how they run the best hardware and networking in the industry, why pairing magical software with the right hardware is the future, and what Open19 means for sustainability in the data center. Think modular components that slot in, including CPUs, liquid cooling that converts heat into energy, and a few other practical solutions that minimize the impact on the environment. But first, we talk about Zach's transition from Packet to Equinix Metal, about his reasons for doing what he does, the big why, as well as the things that Zach is really passionate about, such as the most efficient data centers in the world and building for the love of it. This is a great follow-up to episode 18 because it goes deeper into the reasons why I'm excited about the work that Equinix Metal is doing. Talking to Zach puts it all into perspective. Big thanks to our partners Fastly, LaunchDarkly, and Linode. Thank you for the great bandwidth, Fastly. You can learn more at fastly.com, ship new features with confidence by getting your feature flags powered by launchdarkly.com, and thank you Linode for keeping our Kubernetes fast and simple. You too can run your setup as we do via linode.com/changelog.
What's up, shippers? This episode is brought to you by our friends at Fly. Fly lets you deploy your apps and databases close to your users. In minutes, you can run your Ruby, Go, Node, Dino, Python, or Elixir app and databases all over the world. No ops required. Fly's vision is that all apps should run close to their users. They have generous free tiers for most services, so you can easily prove to yourself and your team that the Fly platform has everything you need to run your app globally. Learn more at fly.io/changelog and check out the speedrun in their excellent docs. Again, fly.io/changelog or check the show notes for links.
We are going to ship in 3, 2, 1.
Well, hi Zach. I've been looking forward to this for a really long time. Summer of 2019, specifically. Welcome, and thank you for making this happen.
Well, Gerard, it only took us a year and a half, but we're ready now.
Yeah, the last year didn't count. It was a crazy one, right? Well, I have many questions, but I'll start with this one. Were you at KubeCon by any chance?
This past in October, was it? No,
Yeah, the North American one.
I wasn't there. We had a great team there, and we were doing our cloud native cookbook. I'm not sure if you got a copy.
I didn't.
Yeah, we decided to organize an open source cookbook that we all did during the pandemic, which was, we're all stuck at home doing something. And so we got, I'm going to call it cloud native luminaries to give us their favorite recipe. And we made a physical cookbook. It's available on GitHub. So if you want to add your recipe.
Okay.
So that was the big giveaway. I couldn't go. I was unfortunately busy with something else, but we did have a pretty good team there. It was, great turnout. Really nice to see people come together.
Right. Okay. So that cookbook sounds great. The fact that you weren't there, it's okay. I missed things, but I didn't miss you. So I'm feeling better of not being there in person. That had been a disappointment. Do you typically go to KubeCons, by the way? Do you have time for KubeCons?
I mean, I used to in the past. Now it's a little bit different. I've gone from being, let's call it a CEO of a startup, a company called Packet, which I ran for many years, to now being a busy executive at a Fortune 500 company, which, I have a little bit different set of responsibilities. And part of that is with customers and in the field, but a lot of that is also internal and part of our strategy. And, I'm going to call it like corporate functionality. So I haven't been to any conferences over the past 2 years, but I used to go regularly. I was on the road 2 to 3 weeks a month, including conferences. To me, that conferences have always been, especially things like KubeCon. And earlier, I remember being at DockerCon in Barcelona in 2015. And so the best part about these conferences to me is the hallway truck. And I just love, seeing and meeting and hearing from, people. You just get that ground, like that pulse on what's going on when you can go around that hallway track and see what people are talking about. So to me, that was always my favorite part of going to conferences. I used to what was my other favorite one? CoreOS Summit, Monitorama, that was a good one. KubeCon, yes. I didn't ever go to like the Gartner IT summits or those things weren't my gig.
Okay, so you're right. That's one of the things which I miss the most about being there in person. So even though I did attend this KubeCon, it was a virtual attendance. But I know what you mean. Like your responsibilities change, and things are a bit different, and you're trying to be there as much as you can in spirit, if not in person. But you're there because I've seen like some pictures you were retweeting from KubeCon. That's why I was thinking maybe you were there.
Oh, we had all of our spies. I think about maybe 15 people from the Equinix team went to KubeCon, so it was good. And my favorite conference ever, I don't know if you have a favorite. My favorite was always the ARM Tech Conference. And
Interesting.
the reason why I loved ARM Tech Conference because it was 100% hallway track. And so they would do, one kickoff meeting in the beginning, some kind of keynote thing, and then they make you all go away and they would take over Clare College in Cambridge. And they would take over the professors' rooms, and you would each have a minder from ARM, and then they would just set up speed dating between all the
Wow,
attendees,
okay.
and you would do half an hour, 20-minute meetings, and then you'd all switch, and then you'd switch again. And so it was basically just hallway track. It was so cool.
Yeah. That's amazing. I think that sounds a little bit like Priyanka's happy hour at KubeCon. But yeah, I really enjoy that format. I know what you mean. Okay, so I've been a fan of Equinix Metal for a really long time. Actually, it's been so long that it was called Packet.
Hearts.
So it's been many, many years. And I've already shared my perspective why in episode 18 with Marcus Johansson and Daniel Flanagan, Raw Code. So there's nothing else to add from my side. But I'm wondering, how was the transition for you from Packet to Equinix Metal? Besides you not being able to go to conferences, which you already got.
Besides having to change my t-shirts.
Yes, that as well.
Yeah, well, I mean, there's a couple of, it's a great question. There's a lot of emotion built into that for me. As a founder, you spend years kind of thinking of something, dreaming on and working on it, kind of pouring your soul into it. And then, in my case, and, we're acquired by a great company, Equinix, and, your role changes, right? It's no longer this thing, especially as a founder CEO, which I was kind of the leader of that, along with my, colleagues and obviously the whole team. But there was a lot of personality built into Packet. Packet was very much shaped in a reflection a little bit of things and values that the founders cared about. And so that is different when you then go into a much more established business, and you have to figure out certainly a totally different challenge in how to meld value systems, culture, brand, obviously, your customer makeup and how you engage and whatnot, and just the pulse of how you run your business. And so for me, that was one of the bigger shifts, which is just going from, Packet was 150 people at its biggest, and we were very much focused and built around speed, right? How do we find product fit? How do we service our customers? How do we listen? Because we weren't market leading anything. We were just trying to prosecute a vision and a mission around making hardware automated for developers. That was as simple as it got. And where that would take us, we weren't exactly sure. And Equinix is a much different business. We're well over 10,000 people. We have 23 years in business, 10,000 customers. Like it is big, and it has a robust and strong culture of its own. And so that was a big shift, just moving from kind of, I'm going to call it the upstart, forward-thinking, future-driven startup to a market-leading Fortune 500 business, and then figuring out my role within that. And then, of course, there was, I'm going to call it personal, emotional ties. I've mentioned this to a few other people recently, but this was a second business that I had sold, a first business of mine. I joined a gentleman by the name of Raj Dutt in the early 2000s, a company he had started called Voxel, which we then sold to a public firm called Internet back in 2011. And I was much younger at the time, and I'd never done that before. And frankly, I didn't deal with it very well. You're taking something that you had so personal, and then suddenly we sold the business, and then I still was taking it very personally. And I wasn't ready to deal with it. Raj went off and founded a company called Grafana. I started to, Packet. And what I did is during this transaction, when we knew we were going to sell the business, first thing I did, talked to my brother Jacob, and I said, man, we're going to have to get ourselves a therapist. And because a lot of this is just dealing with the emotions of a founder because I knew we would change our name, and
Yeah.
things that were special to us would not be important or the right things for Equinix, and
Mhm.
things like that. And sometimes you can take that very personally. And so I think my experience, the first kind of go around, helped me to, in one ways, be a little bit more prepared for it. In the other ways, just know that I was going to go through it. And so
Mhm.
last year, when we changed from Packet and rebranded the business as Equinix Metal, it was still a journey. And, I kind of take a little bit of pride that, I'm going to call it, thousands of people throughout the industry still call it Packet and won't be
Mhm.
able to replace the words in their
Yeah.
mouth. So that's like, okay, fine, because our brand was, meant for something that is important to
Mhm.
people. That's the other thing, is like, so one, your role changes dramatically from what you're doing and where you're at. And two, you got to deal with some stuff as a founder
Mhm.
around maybe the mission that you were on, or the reflection of that up for yourself, and help channel that energy in a positive way. So those are I would say, the
Okay.
two biggest things. Of course, there have been other things which are both opportunities and not related to our product and our capabilities and our scale and all kinds of other things. But those are the ones
Mhm.
that are most personal to me.
Okay. So there's a follow-up question, but first I have to ask another question, which is linked to what you've just said. It was very comprehensive. Thank you very much.
Hmm.
The precursor is, why do you do what you do?
Like the big why or like the little why?
The big why. The big why.
um, yeah, I mean, my wife asks that to me pretty often. So a few things. I can't give you one answer, but I would say that I love creating things for sure, right? I love being involved in that. I love leading it. I love tackling unsolved problems, or just
Mhm.
building. So like, I am a native builder, and you can kind of tell with my personality type. I'm pretty action oriented. I'm curious. I want to kind of unravel and understand, and then I want to do
Mhm.
something about it, right? If I identify a challenge or a problem, my wife hates it because every time she complains to me about something, I try and fix it. And she's like,
Yeah.
I'm not trying to have you fix it. I'm like, I know, but I
Just
want
listen to me,
this.
damn it.
Exactly. I was like, no, I just want to
I
fix
know how it
it.
goes. Yeah, I know. I can relate to that.
So that would be like, I think, why I'm an entrepreneur and why I
Mhm.
have kind of that spirit to kind of create things. And it involves it. I invest in some companies. I like to help other founders.
Mhm.
I always am interested in that creation aspect. And that
Yeah.
really, kind of, I'm going to call it, satiates a need within my own
Mhm.
kind of mind, which I'm always just a very curious person. And then the other one, which is like, why this, right? After the internet, I kind of vowed not to play in the world of internet infrastructure. I was like, I'm going to go get myself a real job, something
Mhm.
that isn't 24/7 with all the, challenges of kind of our plumbing world of the internet. And of course, 2 years later, I started Packet, and I said, no,
Mhm.
I want to work on internet infrastructure and build a better internet. And why did I do that? I think that first and foremost, I really believe in the foundational capabilities that we were able to provide, and I think still provide. And why do I believe that? I think because I think technology really does best, or innovation around technology does best, with diversity. And
Mhm.
that's not just diversity in people and diversity in thought, but diversity in businesses that can take advantage of technology. And so I kind of saw that there was a real need to provide access to fundamental technology to an incredibly diverse set of users and projects and companies, that if we didn't work on making it easier to consume hardware, no matter what it was, where it was, or what you put on top of it, that part of that like messy part of innovation, where the magic of software and hardware come together, would go away, or at least would become much, much more bespoke and, I'm going to call, unavailable to most people.
Mhm.
So that was kind of one of the whys. And then the other big why is that I really firmly believe it. Like, basically, you could kind of say, with all the challenges we have, I think this week is, big climate change summit going on in Europe. And you can kind of say that some of our biggest challenges today can be looked at as something where we could go back and kind of reduce, and maybe even think of a world where we use a lot less technology being computers, but technology even being like cars or something. Or we
Mhm.
can think of a forward way, where we figure out how to use technology in better ways, more sustainable
Mhm.
manners, and use that as kind of lean in to the technology side versus lean out. And I've always been in the latter, right? How to lean
Mhm.
in. And that was kind of one of my, I believe that from just a pure resources perspective, we have to create the right software and the right hardware together, It's not about
Yeah.
making it 10% more efficient. It's about making it 10,000 times more efficient. It's the
Oh,
only
yes.
way that happens. And
Mhm.
I'm sure we'll get to the chips and the things at some point. But
We
to
will.
to me, that was really like one of the imperatives. And the other
Mhm.
imperative, which is why I'm so excited to be where I am here at Equinix, is to change the business model that we
Mhm.
fundamentally have around the distribution of technology.
Mhm.
When you look at a computer, like a server, 70% of the carbon impact of the computer happens in making the computer. Only 20-30% of it is in using the computer for its whole lifetime. And then of course there's, some residual effect of actually recycling if people actually even do that of the computer. And I really firmly believe in moving to a more circular economy. And when you think about the big movements we had over the last 10 or 20 years, where I grew up in the movement from IT to cloud, which is really not a technology shift as much, in my opinion, as a consumption model shift. It was aligning outcomes of the provider. Instead of I want to sell you this server, it says I want to help you use this thing, which is close to like I want you to have the outcomes, that you want. And without addressing, frankly, the OEM and the silicon business models, which currently are in the business of if they don't sell you another chip, they don't make
Mhm.
any money. Now, that's
Yep,
just not a sustainable business model
that's
for
right.
the future of our world. And so the same thing is happening with OEMs who are early, like they're starting to make that shift with as a service, just a little bit, right? But in reality, they still like if they don't build another server and sell you another server, they don't get paid. And to me, these are massive, multi-$100 million businesses. And frankly, especially with the silicon, the main control point for intellectual property, which doesn't have a way to monetize the intellectual property in a sustainable manner. And so to me, that's the other reason is that it started Packet with the idea that we could impact and change the way that technology was distributed and operated because we're going to go through these kind of fundamental shifts in what the things are and who's using them and how the expectations are accessing. Well, if there's going to be a new operating model, now would be the time to
Mhm.
introduce a sustainable business model to the whole thing as well. So that's the other reason why. That's the other big why.
My follow-up question to this was, how did Equinix Metal change your why coming from Packet to Equinix Metal? But I think we can draw the conclusions, like we can draw the parallels, because some of the things that you're alluding to, the scale, first of all, the complexity of like the whole supply chain when it comes to infrastructure. I can think that people can kind of imagine how Equinix Metal makes it easier, not to mention the interconnectivity, all the data centers, so all that, like basically you have a lot more leverage
Yes.
to use in delivering that why. Anything to add?
I mean, there are some positive and negatives to it, right? From back in Packet days, we were, I'm going to call it an arms dealer for transformation as it pertained to this level
Mm.
of the stack, which was just like, I always thought like, hey, there's real estate, e.g. data center as a service, which is a pretty scaled model. There's really efficient capital. There's many providers, of which Equinix, I would say, is the leading provider, right? Definitely by market share and related. But there's like scaled businesses for like if you want to access one of the world's best data centers, you don't have to build one of the world's best data centers. Okay. And then there was this thing called IaaS, right? Which was everything from the computer and the network through like databases and load balancing. Like it was a
Mhm.
whole thing and had a ton of verticalized software opinion built into that.
Mm.
And so what Packet was doing was we were trying to democratize that lowest layer. I call it hardware as a service. How do we enable the consumption of hardware and make it able to touch software, right? And as an independent, we had some advantages which were hard to realize at our tiny scale, but in theory we had some advantages which we could help do this anywhere. And that was an interesting concept. We had put out edge deployments, with tower companies. We had done private deployments with some large enterprises. We were really trying to figure out, hey, where would this be needed? Now, obviously, as Equinix, we're a little bit more focused on our own large scale real estate portfolio. But with that comes some incredible advantages. No longer do we have to think, wow, how could we change this? I'm like, well, we have 240 buildings in 65 markets around the world. We could start there. And,
Mhm.
we can also help our existing 10,000 customers who are really struggling, frankly, with the breadth of our platform and also just figuring out how they are going to react and make a difference related to their ESG initiatives around climate change. And then what they're doing is they're saying, can you help? And what I found is like that's been a really, really collaborative engagement. And what I've been so pleased about working with Equinix versus just, I'm going to call another large company, is that Equinix has the word ecosystem, everywhere. And in fact, Equinix stands for Equality in the Internet Exchange. That was the name of the business.
Interesting. I didn't know that actually.
Yeah.
Okay.
And so, it was created as a neutral place for the internet to grow. And so what I've been really pleased is the support I've gotten throughout the leadership from our CEO, Charles, throughout the rest of the organization and whatnot, in doing a lot of this innovation in the open. And so I get to chair the Open 19 project within Linux Foundation, which is where we work on sustainable cooling, liquid cooling, power, and distribution models for computers, and also in the Linux Foundation for the CNCF for some of our provisioning capabilities and whatnot. So that's been a real joy, as well as looking at the scale and breadth of what we can do to impact and really start a flywheel moving way faster than what we could have done on our own.
This episode is brought to you by our friends at Incident.io. Every software team on the planet has to manage incidents, and a very large percentage of those teams are using Slack to communicate. That includes us. With Incident.io, you can create, manage, and resolve incidents directly inside Slack. Here's how it works. Head to Incident.io and sign up for free, then add it to your Slack. From there, you have a brand new incidents channel where all incidents get announced. Use the /incident command to create and manage incidents. This command lets you share updates, assign roles, set important links, and more, all without ever leaving the incident channel. Each incident gets their own Slack channel plus a high-res dashboard at Incident.io with the entire timeline from report to resolution. Get everyone on the same page from the moment they join the incident and help stakeholders stay in the loop. Add Incident.io to your Slack today and prove to yourself and your team that they have everything you need to streamline your incident management. Learn more and sign up for free at Incident.io. No credit card required. Again, Incident.io. And by our friends at Raygun. Have you ever wondered how users are really experiencing your software? When you unlock real user insights, you'll be able to identify and resolve front-end performance issues and ensure your application is consistently delivering superior experiences. Raygun will deliver a daily performance summary to keep your finger on the pulse of your website with an overview of your slowest pages, core web vitals, user sessions, and user satisfaction. This gets sent straight to your inbox or Slack channel of your choice. Join thousands of performance-focused, customer-centric software teams who use Raygun every single day to deliver flawless experiences to their customers. Again, Raygun.com.
So why do I keep getting drawn back to Equinix Metal? And you're right, it's hard for me to say that, but I have to. I just want to say Packet, but so what keeps me getting drawn into Equinix Metal? The reason why I keep coming back is because you have the best hardware, hands down. So I have been running bare metal servers over my entire career with LeaseWeb, OVH, Scaleway, they used to be called Online, now they merged, Rackspace, SoftLayer, remember them? Remember SoftLayer?
Of course.
And in my opinion, so having all these data points, I think that Equinix Metal does it best. What's the secret?
That's a good one. I don't know. First and foremost, randomly land in this industry and figure out the love. I love this industry, by the way. I love the community around the plumbers, the builders. It's just one of these unique places of the internet that is so apprentice driven and collegial, which is, I think, really special in terms of people who build the lower layers of the stack. It's not something that, I go to cocktail parties or whatever, and people are like, "What do you do?" And I was like, "I work at Equinix." They're like, "The gym?"
Okay.
And so most people don't know what we do, right? But underneath the hood, everybody, I think, really works well together. So that's kind of just like a fun part, and you have to have passion. And I have a strong amount of passion for this part of the innovation stack. So I think that's it. But when we started Packet, we had this like super, super clear vision. And I think I've already repeated it once here, but it was, how can we automate hardware, no matter what it is, no matter where it is, and no matter what software you put on top of it. Like, that was the thing. And what we knew is we knew our place in the world, that if we could enable a highly programmatic way to interact with hardware, no matter what it is, and that's a deceptively simple statement, it is actually extremely hard. And so I was like, this is what we're going to be the best in the world at. We're going to figure out how to enable hardware, no matter what it is, to, this like massive world of software called 40 million developers in the world who want to use all the stuff, right? And they need to make their amazing software work with this amazing piece of hardware, which, by the way, what is this piece of hardware? I think it's one of the most misunderstood things that goes out there. People are like, oh, computers are a commodity, except if you're trying to do something special that changes the world, like make your car go left and right, or talk at the walls all day long, or carry around a supercomputer in your pocket called a cell phone all the time that has all the widgets, right? Like that's where software and hardware come together and create this really magical thing. And so I think our focus on that just pure mission, which was we knew that we had enough there to prosecute that we could spend the vast majority of our careers trying to make hardware accessible for software, knowing the pace of hardware is changing so rapidly. We're like in golden age of hardware right now with the kind of competitiveness between the silicon manufacturers, the business model changes with the hyperscalers, the kind of demand and volume driven by mobile interacting with the kind of like ending of Moore's law in its own regard has just created this huge place for innovation, I think, of software. You also kind of have this natural thing of which I'm happy to play a little bit of a part on, where now multi-arch in the data center is a reality, right?
Oh, yes.
When 5-6 years ago that just wasn't, right? It was x86 or you're done. And now you've got serious languages that have been made multi-arch and have the build capacity and the CI pipelines and the related ecosystem to make that continue and build, kind of quote unquote build upon itself. And so, I think that's happened faster than I expected, where the software has met the hardware, and the hardware is also changing so rapidly that there's just so much to do. And so I envision that over time we'll create a much better, what I'm going to call HCL, hardware compatibility list for the internet that effectively can be an idempotent view of every single piece of hardware ever. And that would allow all the software to be able to choose and understand how to work with it. That's we're pretty far off from that, but I think we can get somewhere there. But I think that's where I'm going to give you your answer, is just like being super crazy, laser focused on what we do. And I spent a lot of time in my first few years at Packet. I'm not going to say like fending off revolutions, but a lot of people, like the clearest one in my mind was I almost had most of my management team, walk out because they said we had to launch load balancers. Otherwise, nobody could use our thing. I said, no, I think software will figure it out. Let's just provide really easy, smaller hardware instances and they'll figure everything else out. And they're like, no, it's too hard. We got to do load balancing. And then look, a couple of years later, you've got ingress controllers and service mesh and, all these kinds of different BGP control and Golang. And like, it's cool. I mean, that's not for everybody, but like software solved the problem. And so a lot of that was just staying super focused on what we did. And I think some of those other providers that you mentioned, of which I'm huge fans and know the founders of most of those businesses and created and moved our industry in their own way, but they became, I'm going to call it all purpose, platforms in a lot of ways. And that's probably right, in some regards, like a lot of the industry has moved to that direction, like especially with hyperscale clouds having these just like robust software catalogs and ecosystems. We've been fortunate enough to have venture backers at Packet who really saw our vision for what it was, which is staying fundamental in the primitives business. And frankly, here at Equinix, which really knows that it is a builder of physical infrastructure that can move at software speed. That's our job. Our job is not to do all the things. Our job is to enable an ecosystem so they can do all the things. And so that has allowed us to kind of continue to focus in on just like, let's be the best at this in the whole world. That's it.
I can see the importance of that. And I can see many decisions which were controversial, such as, let's not build a Kubernetes. Like, what? No, everybody's building Kubernetes. What are you on about?
Oops, I forgot to build a Kubernetes service.
That's exactly the title, yes. That was your one of the great blog posts, which I had the pleasure of reading. And it shows in the small things, but as well as the big things. But for me, one of the reasons, again, why I loved Packet, and now I love Equinix Metal, is that I could provision an instance type, the C3 small, with the highest CPU clock speed ever. You can't get a faster CPU clock speed anywhere. It turbos to 5 gigahertz. Now that creates other problems, but my Erlang benchmarks run fastest on Packet. It's unreal, like 20%, 30% faster, and you can't reproduce that anywhere else. You can get a dedicated instance in AWS and it will not be faster. And that was surprising. And that was like 4 years ago, or 3 years ago. So not much has changed since then. But there is this problem, right? You wrote a little bit about this, the liquid cooling imperative.
Yep.
That's another great blog post. By the way, do you know that one of my favorite downtimes is to read your blog posts?
Uh-oh.
No, they're really good. They're short, they're well thought through, and you convey a lot of information in a very good way. You have compressed information, and they're great. So,
Well, we have a term here for that here at Equinix. It's
what is it?
Well, we started at Packet, and it's due to my twin brother Jacob, which is craft, not crap. So we don't ship any crap content, only crafted content. So craft, not crap.
It shows. It shows. It shows. So the hot chips,
Yeah.
coming back to the 5 gigahertz one, there's the cooling problem. And can you give us a TLDR on that? Because you thought quite a bit. Like, again, I don't want you to reproduce a whole blog post
Sure.
because there's quite, but like as a summary, as a TLDR, why is that important? Because there's another big initiative that is linked to this, the Open 19,
Yep.
and I see a link there, and I can see you being the innovators behind this. But tell us more about that.
Yeah. So, I mean, the TLDR is that chips are getting hotter. Why are they getting hotter? Mainly, we're getting dense. The nanometers are getting smaller on the fab processes. That's how you kind of stuff more transistors in. In order to then do that, you need to push way more power through these things. And we've created innovative ways like what Lisa and team have done at AMD about chiplets and having kind of lower yield requirements and putting multiple chips on a single die, but in the end, like we're just running into the physics barrier here, right? And so you add it by adding more layers onto it. And so suddenly you've got multiple layers into, FinFET or whatever they call it, or even with memory and NVMe, right? So everything is having denser transistors with more power going through them. And you have this kind of movement towards the kind of the way as you kind of get rid of the nanometers, your only way to make things go faster and more efficient is to push more power through it. So that's kind of one in the general purpose kind of like large scale silicon trends that we're dealing with. And the second thing is we have way more sophisticated purpose built technology at this point, like GPUs, right? Or accelerators. We have things that are very, very specific at doing one thing very well. You can then keep them busy, and so you just use a lot more heat. There's an electricity problem that we have there. And certainly as we shift to a more renewable energy footprint, instead of just buying credits and offsets, actually generating things like green hydrogen so you can, offset demand and use it. Exposing, I was in a great panel with the Intel team last week or the week before about how to expose to the world of software reliable metrics on, well, that would not be a good time for you to reindex all of your data stores. Maybe you should do it at noon in our Texas data center instead of at 2 a.m. in our Frankfurt data center, where we don't have any renewable energy. Like we don't have a way to even express that in our industry in a standardized way, let alone to do something about it. We desperately need that, right? But anyways, getting back to it, like accelerators and purpose-built technology and whatever is getting hotter. And so you have this like electricity thing, more juice into the rack and denser effectively. And then you have the other problem, which is cooling. We're kind of getting to the upper barriers of two things. Number one, we're getting to the upper barriers of how we can air cool, this stuff. A lot of the times, and you can kind of see simulations that about 20 to 30% of the energy in a data center is just fans. If you ever walked into a data center, they're very loud. They're loud because there's all these little, tiny 20 nanometer or millimeter fans running at the back of every server, just sucking the air through, just to create airflow on individual computers to pull it over those chips and those heat sinks. And so like in big data centers, you've got 20, 30% of the energy just using fans to pull air around. And then we're getting to this density level where you just can't cool it. There's not enough airflow to be able to do that, especially in a mixed data center. In hyperscale data centers where you can build around one specific thing, you can kind of purpose build some of the stuff around it. You can, as I like to say, build your data center around your computers. You can't do that at some place like Equinix where every enterprise service provider has different things. I also kind of believe that we're going to have a future of compute that's more heterogeneous versus homogeneous. So we're going to have a few of a lot of things versus a lot of one thing. So I kind of think that we have to solve this in a more kind of scalpel driven manner. And so moving to liquid, I'm not going to go into all the things, but just think of it like your car radiator or air conditioning, like pulling a liquid that turns into a gas over the hot part, the chip, the plate, whatever, and then being able to do that does a few things. Number one, it can be way more efficient. You can stop all those fans. You can stop pushing air around, which doesn't go in the right place at the right time, and start to put the right cooling at the right place. Okay. The other thing you can do is create a much, much, much higher differential between the intake and the output. What that allows is you've probably heard of things like heat pumps, right? You can
Yeah,
actually
yeah.
turn that back into energy. So like you've got a natural thing called a giant turbine called thousands of computers creating heat. Well, what does that sound like? Kind of like a power plant to me, right? And right now we literally just exhaust that. We just try and get rid of it. But if you can
Yeah.
create a differential and actually capture, I'm going to call it hot enough liquid, you can actually turn that back onto energy or sell it to the grid for, municipal purposes or whatnot. Like you can use that energy if you can capture it. And I think the most important part of that process is actually today, most of our data centers and most of the data centers in the world use evaporative cooling. And that takes millions of gallons of water per day to evaporate this heat. And that is simply not sustainable. And so we need to move into a closed system where we can keep the water or the liquid and not evaporate it all along with it. So there's these like momentous challenges and opportunities. I think it's like what I touched on earlier related to some of the business model changes are going to be necessary to that. But as we, like, for example, at Equinix, we have a goal of reaching climate or carbon neutral by 2030 using science targets. We have to explore all of these options with not only ourselves, but our ecosystem partners, the silicon partners, the OEMs, our customers, et cetera. I think one of the biggest challenges we have right now is that in an enterprise data center, or this diversity of technology that's going on, everything from Dell servers to NVIDIA DGXs to, boxes that you brought in from your, oh, this is the 10-year-old server I've got, so let me bring it into the colo, right? Still useful. And actually, it's probably one of the best things you could do is continue to use that server so we don't have to make a new one.
Reuse. Yeah, oh yes, reuse. Yeah.
Reuse is like the best thing you could possibly do. And luckily, software is getting sophisticated enough to deal with that, right? At least until we get a more robust, I'm going to call it recycling program built in with the silicon manufacturers where we can recapture that and put it back into use. Well, one of the problems with this diversity is that there's no current standard for how racks get put together. And so if you've ever built a PC, I grew up building PCs.
Oh, yes.
And you used to have an ATX case.
Recently, even servers. I still have it upstairs. 2011, that's the last server which I built, a Supermicro. It's still up there,
There
in
you
the
go.
loft. Not liquid cooled, unfortunately.
In the PC world, we had a standard called ATX. And so you had an ATX case, ATX mini, ATX, whatever. And the cool thing about that was like, if you got an ATX case and somebody else made an ATX motherboard, and on the back of it, you had an ATX, kind of like cutout on the pins, you could kind of make anything. And you didn't have to reinvent the logistics around the computer, like sheet metal and power supply and fan and all those other things. Well, we don't have that in the rack today. Every single rack is like bespoke designed, like as people plug in these servers, well, where are the power cables? Like, well, where's the fans? Where's all the power supplies? None of it is standardized. So it's extremely hard to build these things. Just imagine putting in liquid cooling. Now we're putting water everywhere, right? This is like mechanically complicated and potentially, not dangerous per se, because you're usually going to use some non-conductive liquid, but whatever, right? Like, it's complicated. We've already got hundreds of cables going into the back of these racks. And now we have like water tubes going in and out. Like, oh my God, right? And so that presents a huge logistical thing where we need to create a standard for the rack. And not like everybody build this computer, but everybody build to this standard mechanical form factor. So we can all like connect, almost like Nespresso capsules, like they work in the machine, or like how many things in construction, like outlets, all look the same, right? Well, it's because you create a standard so that the whole industry can work. Maybe Nespresso is a bad example, whatever. But the other thing is actually related to, in terms of creating this like ability to go into racks easier, is so that we can actually design a system where we can take the thing out of the rack. Today, it's so expensive and complicated to put things into market. We never think about how to move them from it. So it's all like it's a one-way street. And then we just like try and get rid of it. And then what we do is we throw away all the stuff. We throw away the sheet metal. We throw away the cables and the copper. We throw away the power supplies. We throw away all this infrastructure around it just because we want a newer CPU.
That's crazy.
That's crazy.
That's crazy. Yeah. Wow.
And so we got to do something about that, right? From a sustainability perspective, but also so that we could do things like put the right technology in the right place at the right time. For example, imagine if we put in your coolest, C3 small processors into Ashburn. They were great and whatever, but it turns out we need some of them in Atlanta. Right now, it's so expensive and so heavy of a lift to move anything from anywhere. We're requiring specialized people and lots of, where are the boxes? Oh, we don't have any standard boxes in our industry. Well, better go get brand new boxes. Like, things like that are just a massive amount of waste.
Yeah.
Well, what if we could standardize and we could like pull out a server sled and, for $10 via a standardized FedEx box, put it into Atlanta? Well, holy cow. Like, I could just imagine the defrag that we could do on our data centers, right? For
Oh,
our
yes.
customers. But that's not a possibility right now without creating some sort of a standard in-rack ATX case. So that way things can go and move, yet innovation can still happen within it.
Is this where Open 19 comes in? Is this it? Basically, Open 19, is this what you've just described, this standardization?
I would say that's the vision, which is instead of kind of dictating the technology, it's around creating an open standard for the mechanical form factor. And that's it. And that's really important because having innovation to occur in both proprietary and open manners is very important for hardware supply chains. Because if you've ever made hardware, it's really expensive to go and do. Like spooling motherboards isn't cheap. Inventing chips isn't free. And so like we need, kind of a robust set of options for the intellectual property model of what the technology that goes inside. But if we could then start standardizing as an industry, especially as our challenges around power and cooling and heat capture become like front of mind for most companies and an imperative for all of us, that's going to provide a really amazing outlet for all of us to work together, OEMs, customers, supply chain, data center operators, et cetera. We've chosen to invest in Open 19. It has a special kind of blind mate connector design. And so the idea is that you shouldn't ever have to go to the back of the rack, that you basically have a sheet metal, kind of cage. And on the back, you have blind mate power, blind mate data, and soon blind mate liquid cooling loops. So that if you have a server that can mate with those, it automatically engages. But you never have to go to the back of the rack and do all this complicated stuff.
Yeah.
So my vision would be that FedEx, driver can literally come in, walk it in, slot it, and walk away, and it would work. That would be the dream. We're not there yet, but if we can get there, wow, that would change, I think, how we use technology.
Yeah, I would get 2 of those, please. Like, can you just send this FedEx guy to like up in my loft and slot 2 of those in? I would definitely want 2 of those as well.
And especially if we could do it with you just think about places like Equinix or whatever. Like we could do it with reusable packaging. Like, okay, it's a brick. It's of this size. We got a package. Like we plop, here's your thing. We'll come back with the brick if you want to move it. Like we'll come back with the reusable box. And I think that in and of itself is a huge, reducer of waste, but it could enable this movement of technology to the right place at the right time.
Yeah. This sounds an awful lot like containers for software. That's exactly it. Like, this is the standard.
Stuff it into here.
Create the standard, and everything is just going to slot in. Like, spin up the container. And that's it. Well, okay.
That's a good phrase. And we can use our physical infrastructure at software speed. Then we need to create the Kubernetes is to the container as something is to the physical hardware movement.
I was too busy creating the hardware equivalent of Kubernetes. That's why I didn't create Kubernetes. Okay.
There you go. You've uncovered the secret.
What's up, shippers? This episode is brought to you by Equinix Metal. If you want the choice and control of hardware with low overhead and the developer experience of the cloud, you need to check out Equinix Metal. Deploy in minutes across 18 global locations from Silicon Valley to Sydney. Visit metal.equinix.com/justaddmetal and receive $100 in credit to play with. Again, metal.equinix.com/justaddmetal.
So you mentioned about multi-architecture becoming a thing, a big thing in the data center. And I have seen, at least for developer workstations, like when it comes to the new Apple M1 chips, I think they're amazing. I don't have one, but I'm looking forward to it.
Right.
I know that Intel has always been great for single core clock speeds. That's why I was mentioning the 5 gigahertz. But if you need lots of cores, AMD, I think especially with the Rome architecture, really had a home run this year. I was following it. It's just amazing. And my dev workstation, it's an AMD EPYC Rome.
Hmm.
Rome is a second generation of AMD EPYC, but I'm not sure whether all listeners know that.
Don't worry, here comes Milan. It's coming out soon.
Right. So how do you see this between Intel, AMD, ARM, like the whole chip play? I know that you provide ARM servers, but I haven't seen them publicly. But what does this multi-arch look like from an Equinix Metal perspective? And from your perspective from chips, because you love chips even more than I do, love chips.
Yeah.
And I mean the CPUs, I don't mean the chips that you eat.
So let's see. I mean, the best way I can answer is like I loved investing in the ARM ecosystem because it really pulled us as a company back in, I think it was 2016 when we launched the Cavium Thunder X, which was the first kind of 64-bit server capable ARM processor that you could buy, right? There was a few before that, but they didn't really come to fruition enough to be able to kind of general purpose. And the reason why we did that, which a lot of people questioned me from that time, especially at our company, they're like, we had a very open and transparent business, which I was always very proud of. And people hopefully felt that they could say what they needed to say or whatever they thought. And some people said, like, why are we doing this ARM stuff? There's just no money in it. And I said, it's because we need to force ourselves, kind of like how we found a lot of cloud native developers developed on Packet or on Metal because it forced them to be, not reliant on, cloud provider services. Because we didn't provide any. We couldn't get stuck on our load balancer because there wasn't one.
Not our problem.
But that's what I wanted to do with moving to ARM, was making sure that we could be really agnostic around what the technology was. And, I always like push people internally and said, hey, whether it's, Intel or ARM or some other thing that somebody invents, which I'm sure they will, we want to be really good at turning it on and off in a repeatable, secure way for our customers and helping the world of software to touch it. And so ARM was a really great opportunity to push that envelope because nothing worked. Like everything you thought would work, like, oh, well, boot. Well, not really. Oh, UEFI. Oops, that's a little different. Oh, iPixie, different. I mean, all kinds of things throughout the boot chain process and whatnot had to be worked on until you could do it. And I remember sitting with Syed, who's the CEO of Cavium. I was like, we're going to need to like provision and delete these things like thousands of times a day until it is boring. It's just not boring right now, And then we'll get like Debian and CentOS and Ubuntu and some other things working on it every day, boring with all the build things and all the repos and all the things that needed to get re-architected and multi-arch for that. And I remember one of the first ones we did is I called up, what's his name? He used to be a client of mine way back in like the early 2000s, but he was the maintainer of the build infrastructure for Golang. And I remember calling him up through a friend and basically being like, yo, you work at Google, can I give you, access to our Works on ARM ecosystem so you could start doing builds of Golang natively on ARM? He's like, well, you could always compile it yourself. I'm like, yeah, but like that's a lot of work for everybody to do every time they wanted to try, and so, we just kind of slowly built that up. And that was a really cool way for us to make sure that we were being agnostic on architecture. Now, of course, later, Intel was challenged by AMD with their chiplet architecture and the, Lisa's kind of forward-thinking vision, Mark Papermaster and whatnot, creating a purpose-built, I'm going to call it technology or chip architecture for the cloud era, just provided a huge amount of competition and an alternative in the marketplace. But now you've got this, we'll see, but like NVIDIA is buying ARM, right, or at least attempting to. I'm not sure what's the state of the regulatory approvals or whatnot. But now you have these three really good, really competitive. Now the path back at Intel, he is like moving hard from what I can tell on the outside. And it's great to see three giant, pretty consolidated chip companies all fighting it out. This is good, right? This is really great. And then in the meantime, you have people like Amazon creating Graviton and pushing the limits there and showing what's possible, or Apple doing M1, and now even developers. I mean, I was on a podcast with a developer friend of mine recently, and he was talking about how much he loved developing on ARM. I was like, you wouldn't heard that 3 years ago. He's like, but it's so much faster to do it natively. I was like, whoa, ARM laptops, here we go, right?
Yeah.
It's like Ubuntu on your desktop, right? It's going to happen one day. And so I think you've just got this like, nice, healthy, competitive silicon environment. You've got a bunch of different technology tracks that people are going off of. And frankly, the software world has become, because of both, I think the two kind of critical ones, Apple having, moved to ARM for its own chip, that's going to help make a lot of developers, experience native ARM architecture. Obviously, the mobile world has carried that through. And then the second one is with cloud providers like Amazon even adopting their own ARM technology. I think that really will just like cement a multi-arch world, which will prepare us for whether it's open power or risk, things that are truly open ISAs, and that's the difference there is that whether it's ARM, which is still a licensed instruction set, or x86, similar, and then we'll see maybe Intel will also start licensing it. But RISC with RISC-V and Open Power are truly open, right? And they have no intellectual property ties to them beyond, their licensing regime, but an open source license, which is really neat. Because in my opinion, that's where the next phase of super bespoke chips comes out of, right? Where you can use an architecture really liberally. And I think we haven't seen that yet. I think like RISC-V it's on the radar, but it's not here. And so whether it's SoFi or or whatnot come to market, but some way where we could see companies of all sizes, maybe even like pretty early companies developing and having their own chip that just did their workload. Would be pretty cool. More Apple M1s, but for different companies.
So you're the second person that I know of who speaks very passionately about risk. Dan Mangum from Upbound Crossplane, he's the first one. And I know that he's really passionate about RISC-V. Besides the open model, the open source model, is there something more to it? Is it like the potential that what could become, what RISC-V could become, and the chips that could be built with that instruction set? Is that what gets you really excited? Is there anything else beyond that? Because right now, it's very nebulous, right? It could be an amazing thing, but if you were to use it, like you can use ARM today. Can you use RISC-V today? I don't think you can. There's like no implementation of RISC-V as far as I know.
There's a great article or a great podcast I listened to, maybe it was last year from NPR about RISC-V. But it was great. Yeah, people are using RISC-V just within their own proprietary silicon. For example, some of the big machine learning products and whatnot use a ton of RISC-V. And I think where it comes down to is that although the licensing model will be good, and certainly I'm going to call it a liberating tool that will just kind of create competitive and licensed models. I think it's really just going to be the overarching like assembly. Like RISC-V is a pretty new language, or a pretty new language, ISA, which is like, this is an architecture built recently. That's kind of cool.
So modern is what you mean by that. Yeah. Okay.
And I think that's powerful. I'm not smart enough to even understand what that means. I just kind of have to believe that there's some pretty big advancements we've all made in 20 years in terms of how we can build architectures. And so, I think that that's going to be the fun part, is to see what comes out of that and where people can take as it gets more mature. And there's like line on chip factories for that, from the silicon fabs. Like, okay, wow, that will be cool. What if you could, produce a chip that just did this one thing that your software needed? And that's where you get into the oops, I did it 10,000 times faster or more efficient thing versus anything else. And maybe the barrier to that just goes way down, like kind of how ARM did it for certain parts of the market, but maybe for the next phase.
So I'm going to mention now the third article, the third blog post that you wrote, 5 predictions for hardware in 2021. I really enjoy that. I would ask you how they played out, but let's leave that for another time, if ever. I'm more curious about your 2 predictions in hardware for 2022. Do you have any?
Oh, that's a good one. I haven't thought about it yet, man.
Well, you have to, because I'm looking forward to that blog post.
Yeah.
And you have to start writing it.
Well, don't hold me back into 2022, but the 2 most interesting things I think of related to hardware right now. First and foremost, we're going to have to solve the sustainability problem, right? This is just not going to work. And so whether it's because people come out with licensed CPUs, like sign up for your subscription to technology from whoever versus buy this thing. And also the related kind of, I'm going to call it surround sound stuff around, the cooling, the power, the whatever. Like we're going to have sustainability. Silicon is at the heart of that. Hardware needs to become a sustainable circular economy. It is not currently today. That's what we got to take. Okay. So that's like probably not going to be done in 2022. But
at least the beginning of that, yeah.
I think we're going to make progress on it. And, we already see it happening throughout our industry, which is regulatory impacts, customers. All of our biggest customers bring sustainability as their number one issue now. It didn't used to be
That's
there.
a good one.
Even 18 months ago, it wasn't even on the radar. Now, right at the top. And so, okay, that's great because now we see business drivers. I think people are going to pay for this too, which is really important, is that you don't just get sustainability for free. We don't get to
Yeah.
just do, oh, we did green power for you as a good marketing thing. No, 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 no. We invested tons of money to make meaningful impacts to change our world. That is going to cost money. We are going to invest together. So I think like that's an important thing. All right, that's number one. I think actually number two is that at some point, if we can solve this distribution of technology, right thing in the right place at the right time. So that way you could pull up on your iPhone and see the tracking of your cool computer to the right market and it just turned on. And if we could snap our fingers and let's say you figured out just the right technology that you needed to use for your platform, and then you clicked a button or hit an API call, and somebody like Equinix got it into 50 or 60 markets around the world in like a couple weeks. That would be rad. And I think we would see disruption in content delivery and CDNs and edge computing and all kinds of things that we would do in networks and all things that could run on, I'm going to call it hardware and software moving at their own pace. So pending we solve this distribution thing, I think the big, and this is again, probably, you have to ask me what's the 2025 predictions. That's way more my style. But 2022, I'm not so sure. 2020 something, the other thing I think is going to be security. Right now, people just try and get the hardware or the thing in the right place at the right time, and they're lucky to have it, and they go like, that is not going to be kind of our long-term challenge. We'll solve that. Then we need to solve a way different approach to security, and that has to start at the hardware level. So I think our kind of like enablement of hardware level security has barely begun. Most people don't think about it in the software enablement side. They think about, oh, I'm going to encrypt my stuff. I'm going to get my like TLS going. I'm going to do all those things. But really, I mean, even things like basic time protocols, basic boot process. Is this machine the thing I think it is? Who touched it in the supply chain? I always say, like, why hack the app when you could just hack the $1 chip at the factory? Like,
oh yes.
So I think we got to start thinking about like a zero trust approach to hardware. And that will allow us to like increasingly move these very, very important parts of our life into hardware we never touch or operate ourselves. We have to trust a third party. I don't know. You shouldn't trust the third party. But right now, we don't have a mechanism for third party hardware to be zero trust. And I think that's like the next biggie wave.
So I know, like supply chain security.
2020X.
Yeah, 2020X. Yeah, I can see that one, even like in software, like where we have been doing it for long enough. When it comes to containers, when it comes to various CI/CD systems, when it comes to different platforms, even how software moves through those different platforms, and you shouldn't trust any of them. How do you ensure things are secure? How do you ensure things remain signed? So I can see this being a big thing coming. Coming back to what you mentioned earlier about sustainable hardware, and how we cannot throw away hardware. We have to replace the parts which are broken or, are obviously like an advantage to upgrade them, like the CPU, without upgrading everything else. And making it so simple that the FedEx guy or gal can come into a data center and just plug it in. That's what
robot.
we want.
FedEx robot.
Yeah, that as well. It may happen. So it can happen, and maybe should happen, right? Because this is like the whole more sustainable hardware, more sustainable economies of scale, because they have to be big, right, for them to work. And you're right, it is top of the mind for many people, especially this week. So I can see a very nice link, and I'm sure that you can see it as well, between what you've just mentioned and Equinix Metal. So how does this map to the Equinix Metal priority for 2022? I know that you promised priorities in a few weeks in your last blog post on November 4th.
You're trying to get a teaser. You can't do that.
Yes, just one. Just one. He promised a few. I just want one. So can you give us one?
Well, I think we'll make meaningful progress on kind of the distribution capabilities. I always like to tell people that Equinix Metal is not a bare metal cloud. We're a hardware distribution platform, an operator for fundamental infrastructure. And so we'll enable more places where you can do that. We've been really fortunate to be able to invest heavily and put Equinix Metal in 18 markets around the world. I think we'll expand that and go to more. I think though that what we'll do is we'll move this my predictions is that we'll move some of these things which are kind of loosey goosey right now. Like we're going to do field trials of our pluggable liquid cooling. We've already been doing it for about a year in one of our data
Ooh,
centers. We're going to move there with customers in the coming months using some prototypes that we've been building. So we'll move out there and we're
interesting.
going to do that with some partners, OEMs, supply chain partners, et cetera. So I think that will be really important because we have, as Equinix, we're fortunate to be always building data centers. I can't remember from our last earnings call how many are under construction right now, but it's a lot. And so we have this opportunity to really optimize and change kind of what we're putting into the ground around some new hardware delivery models. So my hope is we'll make progress on that and hopefully with customers and in the open so that everybody can learn and we can try and, let's say, exit 2022 with a super clear path to disruptive sustainability from a power and cooling perspective.
I love that. That's something I can get behind. Oh, yes. Yes, please.
I haven't found somebody who can't get behind that. Everybody's
Oh,
like,
yes.
that makes a lot of sense and I want to be part of it. So I think making sure to do that in an open way is going to be really important. And the second thing is like, I think we're going to see the OEMs, Dell, HP, Cisco, Lenovo, et cetera, even NetApp and, F5s and Pure and, all these other people who make purpose-built technology in hardware. I think we're going to see just massive business model shifts. Like the cat's out of the bag. People want aligned business models as a service. And that's going to be a really, really big turn for these aircraft carrier style companies. They're big businesses that are really used to shipping you the technology and you doing everything. And now they're going to turn it and running it for you somehow. We're going to feel the ripple effects of that. But I'm so excited about it because that's the first leading indicator of how we can make the kind of business models more aligned. And people sometimes, originally inferred that Equinix Metal was kind of in conflict with cloud providers. I don't think so. We've recently enabled things like Amazon EKS and Anthos, because I see cloud providers as software companies that when at the right scale, they'll run aggregated infrastructure for you. But when
Oh,
not
yes.
at the right scale, called pretty much anything beyond multiple megawatts, they don't really want to run the technology for you. They just want to sell you the software and services. And I think that that's a pretty aligned model with hyperscale that we can help support. And with OEMs, as they move into this kind of as a service model, I think we can be super helpful with Equinix Metal to help them be the best in the world with that. It's one of the main reasons why, 2014, we've been making it so that we can automate hardware no matter what it is and where it is and what runs on it. We might want to add one other thing is like, or who owns it, because it doesn't really matter, right? Your server, my server, Dell server, it's just a server, right?
Yeah.
And can we make it consumable and usable? That just requires, frankly, that's a startup guy talking. It just requires a business model change.
Yeah. That's simple, right? We'll figure it out. Yeah.
Let's figure that out. Pull request on version 1.2 of the business model.
Exactly. Or send me your pull requests and I'll consider
I'll
it.
consider it.
I'll merge it. Who knows? Maybe. Okay. So as we are about to wrap this up, I'm wondering that, like from a listener perspective, if there was one thing that I would take away from this conversation, what would you like it to be?
Well, I would like more people, especially software-minded people, to be interested and open to, I'm going to call it the disruptive innovation that can happen when you pair magical software with the right hardware. I think it's not only super cool, I think it's an imperative for us long term to be good at that. Not everybody, but I think that that's an open place. And I'd love people to come away excited about the opportunities of making a difference with technology, about doing so in a sustainable way. And not just because it's like good for the granola country planet. It's like because it's like both good for you and like doing good, but doing what is it? Doing well by doing good.
Yeah.
Another one of my blog posts a year or two ago, which is about creating a bigger tent, like an ecosystem driven way where we can create more value by solving these problems together instead of, I'm going to call it a siloed way where we take the value. It's like the carbon industry right now where, instead of pulling in like raw resources and extracting them for ourselves called like drilling for oil, like we can create new technologies like, renewable solar or, even carbon capture, like what Stripe's doing with that. But like that's a way that you can do well, but also create a bigger opportunity tent. I think that's the other powerful part that I'd love to impart to software minded users is that, we can really work together between software and hardware to solve some of the biggest challenges of the world. We cannot do it on our own, but together, that's a pretty powerful combination. And I'd love to be part of that ecosystem.
That's a really good one. And I know that Tinkerbell OSS is a great example of what you've just said. So if you're wondering, like, this sounds a bit hand wavy, well, no, because there's actual projects that you can go and check out, and they look really good, which shows the investment and commitment to those technologies. The Hotel CLI is another one, and there's a couple of other examples in the Equinix labs, which is a great way to see some of the ideas which float around. And
Yeah.
I'm sure new oన్స్ will appear next year.
Tinkering with hardware and software together, come on by.
Tinkering. I love that. Like, where did Tinkerbell come from? Tinkering. There you have it. Let's tinker with hardware. I love it. Zach, thank you very much for indulging my curiosity. I had a great conversation about hardware, and you gave me some crazy ideas for 2022, and I would love to have you back at Ship It. Thank you very much.
Appreciate you having me here.
Thank you. Thank you for tuning into another episode of Ship It. I enjoyed making it for you. This is just one of the podcasts for developers that we ship. Go to changelog.com/master for the rest. You can join me and the rest of our community at changelog.com/community. There are no imposters in our Slack. Everyone is welcome. Huge thanks to our partners Fastly, LaunchDarkly, and Linode. Thank you Breakmaster Cylinder for all our awesome beats. That's it for this week. See you next week.